All right, Monday, March 23rd, 2020. All right, let's get these three limit problems out of the way. So this is problem number 1, problem number 2, and problem number 3 is down there, okay? I did the work on the side, that's why it's covering. Okay, so let's take a look at problem number 1. You'll notice that all these are familiar. They're from the simplifying rational expressions. I'm just gonna add a limit to it just to make it complete. So the limit as x approaches 2 for x squared minus 11x plus 18 over x squared plus 2x minus 8. Spoiler alert, it's going to be a 0 over 0 limit. So let's factor. So we're going to factor the top. What two numbers multiply to 18 and add to negative 11? Well, that combination needs to be negative 9, negative 2. So that top factors into x minus 2 times x minus 9. The bottom, what two numbers multiply to negative 8 and add to positive 2? That combination needs to be a positive-negative combination. In particular, the positive is stronger than the negative. So it has to be x plus 4 times x minus 2. And you'll notice that the top and bottom both have an x minus 2. And we are trying to find the limit as x approaches 2. So if I plug in x equals 2, you get x minus 2 over x minus 2. You get 2 minus 2 over 2 minus 2, 0 over 0, that'll be $400. We got a hole in the graph. So we cancel out the hole in the graph, leaving us with just the limit as x approaches 2 for x minus 9 over x plus 4. Yes, you must put the limit as x approaches 2 until you can actually plug in x equals 2. So this is the same exact graph as the limit as x approaches 2 of x minus 9 over x plus 4 is the exact same graph as the blue problem, x squared minus 11x plus 18 over x squared plus 2x minus 8. The only difference is now we know that x equals 2 results in an indeterminate form, a hole in the graph. So now is it legal to plug in x equals 2? Yeah. So we've got 2 minus 9 over 2 plus 4, or negative 7, 6. I just cleaned it up and put the negative in the middle of the fraction. Okay, so what this means is as x approaches 2, as x gets arbitrarily closer and closer to 2, y gets arbitrarily closer and closer to negative 7, 6. However, the point 2 comma negative 7, 6 is actually a hole in the graph. Okay, see if you can do problem number 2 independently by pausing the video. Okay, so we take a look at limit as x approaches 3 for x squared minus 8x plus 15. Spoiler alert, it's going to be 0 over 0 because if I plug in x equals 3, let me get my pencil. You'll notice that if I get x equals 3, I get 3 squared minus 8 times 3 plus 15. That'd be 9 minus 24 plus 15 over 9 minus 9. So that'd be 0 over 0. We've got a hole in the graph. The difference between pre-calc and calc is when we get into pre-calc, it just says, oh, there's a hole in the graph, let's just give up. But when we get into calculus, it is, where is the hole? So we need to factor the top and factor the bottom until that hole goes away. What two numbers multiply to positive 15 and add to negative 8? It has to be two negative numbers. Negative times negative makes a positive. Two negatives added together makes more negative. So that combination needs to be negative 5 and negative 3. Now, we look at the bottom. Straighten the tie, everybody. Everybody straighten the tie. X squared minus 9 is a pair of conjugates because x squared minus 9 is the difference of two squares. X squared minus 3 squared. So that becomes x plus 3, x minus 3, a pair of conjugates. So now we've got x minus 5 times x minus 3 on top over x plus 3 times x minus 3. And if we plug in x equals 3, we get x minus 3 over x minus 3. 3 minus 3 is 0. 3 minus 3 is 0. 0 over 0. There's a hole in the graph. That'll be $400. We got to cancel it out. So now that we've canceled out, we've got the limit as x approaches 3, because we haven't plugged in 3 yet. We acknowledge x minus 5 over x plus 3 creates a hole in, there's a hole in the graph at x equals 3, and now it's legal to plug in x equals 3 to find out where is the hole. So now we plug it in. 3 minus 5 over 3 plus 3. That's going to be negative 2 over positive 6. Can that fraction be reduced? So it's a negative on top over a positive, so the fraction is going to be negative. We're going to simplify 2/6 to become 1/3. So the limit as x approaches 3 means, the limit as x approaches 3 is negative 1/3, because as x gets closer and closer and closer to 3 in this graph, y gets closer and closer and closer to negative 1/3, but it will never actually reach it. Final one. We plug in x equals negative 7. We get negative 7 quantity squared plus 3 times negative 7 minus 28 over x squared minus 49. We get 49 minus 21 minus 28, or 0. Negative 7 quantity squared minus 49, that'd be 49 minus 49, or 0 minus 0. So we get a 0 on the top and a 0 on the bottom, therefore there's a hole in the graph. So if a 0 over 0 creates a hole in the graph, that's what's called an indeterminate form. So in pre-calc, we say there's a hole, let's just give up. In calculus, we say there's a hole, let's find out where the hole is. So we have to get creative. Sorry, I didn't want to spoil the answer. We get x squared plus 3x minus 28. What two numbers multiply to negative 28 and add to 3? So it has to be a positive-negative combination, where the positive is stronger than the negative. So we have positive 7 and negative 4. That multiplies to negative 28. 7 minus 4 is 3. So the factored version on top becomes x plus 7, x minus 3. And on the bottom, straighten the tie, x squared minus 49. That results in a pair of conjugate. Logan's right next to me. He wants to see this. So Logan, straighten the tie. Conjugates. Say conjugates. Conjugate. Now he doesn't want to talk. X squared minus 49. So x squared minus 7 squared can be rewritten as x plus 7, x minus 7. So now we've got the limit as x approaches negative 7 of x plus 7, x minus 4, over x plus 7, x minus 7. If I plug in x equals negative 7, I get negative 7 plus 7 over negative 7 plus 7, 0 over 0. That'll be $400. That's the hole in the graph. But in calculus, we say, where is the hole? So now, again, because I have not plugged in x equals negative 7, we say the limit as x approaches negative 7 of x minus 4 over x minus 7. And now it's totally legal to plug in x equals negative 7. So we've got negative 7 minus 4 over negative 7 minus 7. Negative 11 over negative 14. Can't simplify the fraction, but I do know that a negative divided by a negative is a positive. So this has to be positive 11/14. So as x gets closer and closer and closer to negative 7, y gets closer and closer and closer to 11/14, but it never actually reaches there because it's actually a hole in the graph. So why am I telling you this? This is just review. Because I'm giving you guys a new power-up, kind of like Super Mario Brothers, where the later levels give you like the raccoon costume or the propeller. Now we're going back to level 1 to make level 1 significantly easier to get all the hidden coins. Okay, so I'm going to turn this around, blah, 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 blah. I don't want to spoil it. So, a new topic. Sorry, a new tool. L'Hôpital rule. Everybody say, L'Hôpital. 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 So the idea of L'Hôpital is the limit as x approaches a of f of x over g of x. You try direct substitution and you get 0 over 0 or infinity over infinity. We will deal with infinity over infinity later. But the idea is, for now, you plug in the value of x and you get 0 over 0. If direct substitution of a limit results in 0 over 0 or infinity over infinity, this is called an indeterminate form. 0 over 0 indicates a hole in the graph. Infinity over infinity is something else, but for now, 0 over 0. So if The limit as x approaches a of f of x over g of x results in 0 over 0 or infinity over infinity, then the limit as x approaches a of f of x over g of x can be rewritten by L'Hopital's rule, the limit as x approaches a of f prime of x over g of x, or g prime of x. So the limit as x approaches a of f prime of x over g prime of x. Notice that I put an LH on top of the equal sign. The reason why is because let's think about this. F of x is not equal to f prime of x, and g of x is not equal to g prime of x. Logan, you need to get off of me. Okay, thank you. Okay, so sorry, I got Logan right next to me. So in other words, if your limit results in 0 over 0, take the derivative of the top, take the derivative of the bottom until that 0 over 0 problem goes away. So let's do some easy versions. In fact, let's do the 3 problems that we just did using our superpower, L'Hopital rule. And I'll never forget this because I learned this in Calculus 2, because limits for me were actually very hard compared to derivatives. I actually liked derivatives much better than limits because I was like, how's this different from algebra? And then in Calc 2, my professor goes, you know, there's this thing called L'Hopital rule where if you have a limit as x approaches a and you get a 0 over 0 for direct substitution, you could just take the derivative of the top over the derivative of the bottom. And all of us were like, what? You mean to tell me that this was easier? Because I mean, I was really, really good at factoring, but we'll see later there are going to be some problems where you can't factor. You got to do something called multiplying by the conjugate. You gotta get creative in some way. So now let's take a look at problem number 1. The limit as x approaches 2 for x squared minus 11x plus 8 over x squared plus 2x minus 8. Once again, angry Isaac Newton. If I plug in 2, right, this is his thought bubble. 2 squared minus 11 times 2 plus 18 over 2 squared plus 2 times 2 minus 8. You guys know how this works. You plug in x equals 2. I'm not happy. There's a hole in the graph. And even though I'm crossing it out, it is part of my work. Once again, you can only use L'Hopital's rule for an indeterminate form. You can't just do it for every single limit. So, that being said, I indicate that the right side of the equation is the derivative. No, it's not quotient rule. So, you take the limit as x approaches 2 of the top getting ddx'd and the bottom getting ddx'd. So now, let's complete this problem, okay? So, you've got the limit as x approaches 2. And now we're going to take the derivative of the top. What is the derivative of x squared with respect to x? 2x. What is the derivative of negative 11x? What is the derivative of 8? 0. So that becomes the new top. And now we've got the derivative of the bottom. Let's take the derivative of x squared with respect to x. That's, yet again, 2x. And the derivative of 2x is just positive 2. And the derivative of negative 8 is just going to be 0. Okay? Hey, Logan, can you hand me that red pen over there? Okay, thank you. All right, so now, is it totally legal for me to plug in x equals 2? Yes, there's no problem, because if I plug in x equals 2, 2 times x minus 11 over 2 times x plus 2. So I'm going to plug in x equals 2 to the top and bottom, and I'm going to get 4 minus 11 over 4 plus 2. So 4 minus 11 is negative 7. 4 plus 2 is 6. So therefore, we got the same result as earlier. The limit as x approaches 2 of x squared minus 11x plus 8 over x squared plus 2x minus 8 is literally negative 7, 6, the exact same solution as the factored way we did it. Now, I looked at this like I've just seen, you know, the Thanos gauntlet or whatever it's called. I was like, you got to be kidding me. This is way better than, because it's just one technique. If I have a 0 over 0, take the derivative of the top, take the derivative of the bottom. So now let's do the other two problems, but with L'Hopital rule. See if you can do problem number 2 on your own. And I just spoiled for you the 0 over 0 part. Again, because we both know that they're going to be 0 over 0. See if you can do problem number 2 independently. When you're done with that, see if you can do problem number 3 independently. Okay. So let's take a look at problem number 2. The limit as x approaches 3 of x squared minus 8x plus 15 over x squared minus 9. Plug in x equals 3. We've got a hole in the graph. Isaac Newton is not happy. So we've got the derivative of the top over the derivative of the bottom. What is the derivative of x squared? 2x. What is the derivative of negative 8x? Negative 8. And the derivative of positive 15, the derivative of any number without a variable, so a derivative of any constant is just 0. And the derivative of the bottom, let's take the derivative of x squared. So the derivative of x squared is 2x. The derivative of negative 9 is just 0. Now, is it legal for me to plug in x equals 3? Yes. So I'm going to plug in 2 times blank minus 8 over 2 times blank. So now what goes in the blank? The 3. So now I get 2 times 3, which is 6, minus 8 over 6. Now 6 minus 8 is negative 2 over 6. Can I rewrite this? Yeah. A negative divided by a positive is a negative, and 2 6 would be 1/3. So the limit as x approaches 3 of x squared minus 8x plus 15 over x squared minus 9 is negative 1/3. The point 3 comma negative 1/3 does not exist because it is a hole in the graph. So now, problem number 3, spoiler alert, we get 0 over 0. You guys want to factor or do L'Hopital rule? That's what I thought, L'Hopital, because I put LH. But once again, we're going to do the limit as x approaches negative 7, take the derivative of the top. The derivative of x squared is 2x. The derivative of 3x is positive 3. And there's no letter next to negative 28. The derivative of negative 28 is 0. Take the derivative of the bottom. The derivative of x squared is going to be 2x. And the derivative of negative 49, there's no letter attached to it, so the derivative of negative 49 is 0. Good job, Logan. So now I'm going to plug in negative 7. Is there a crime? There's no problem. So now I'm going to plug in x equals negative 7. And now we've got negative 14 plus 3 over negative 14. So that's going to be negative 14 plus 3 is negative 11 over negative 14. I can clean that up. I can't reduce 11 over 14, but I know that a negative divided by a negative is a positive. So the limit, sorry about that. So therefore, as x gets closer and closer and closer to negative 7, y gets closer and closer and closer to 11/14. But negative 7 comma 11/14 does not actually exist because it's a hole in the graph. Thank you, Logan. All right, so just to give you a preview, why am I going over the easy ones? Well, to give you a preview of what we're doing next is one of the things that drove me insane when I took college in 2000, When I was in high school, I took pre-calc, and I got a preview of this from my pre-calc teacher who had long hair and a beard. And in 2007, I took from a guy with short, spiky hair. And I finally understood it in 2008 from a really good teacher, but they still taught the same way about this. This is one of those things called an axiom. In other words, we don't question it, we don't question why it works, it just does. The point is, if I do the limit as x approaches 0 for sine of x over x, I get sine of 0 over 0, I get 0 over 0. There's a hole in the graph, and Isaac Newton's not happy. Let me give him some long hair. He's not bald. Anyway, so these three different teachers all agree. You know, Matt, just memorize it. Just don't question it. And it wasn't until I took Calculus 2, and I got L'Hopital, and I actually tried it. And let's see what happens if I try L'Hopital. So if I L'Hopital the top and the rational expression, I still write the limit as x approaches 0. Sorry, I'm holding the iPad in my left hand and writing with my right. So anyway, so go back to our derivative unit. Well, I'm going to do the bottom one first. The derivative of x is 1. What is the derivative of sine of x? Well, the derivative of sine is cosine. Do I need to do chain rule? No, I don't, because it's just x. If I did the chain rule, the derivative of x with respect to x would be 1. So the point is, the derivative of sine of x is cosine of x. And now, the limit as x approaches 0, just to be neat, is just cosine of x. Let's plug it in now. So now I've got cosine of 0 radians, just to be specific. Whenever you're in calculus and you've got trig functions, you're in radians, not degrees. But luckily, it's not going to hurt us this time. I might give you something like pi over 2, or pi, or 3 pi over 2, or pi over 3, something like that. But the point is, you're always in radians, and that's why I taught it. So cosine of 0 radians is, in fact, 1. And that's why it works. L'Hopital. We're going to do more L'Hopital in the next class date. Hope you guys have a good day, and I'll see you guys later.